Hey guys, so here we have a 13 kilogram object and it's moving 4 meters per second. So we know we have a kinetic energy to begin with. So here when it says what kind of energy before, we've got kinetic energy. Alright, and then it comes to rest by compressing a spring 0.5 meters. So find the spring constant of the spring. So we want to know what is K. Anyway, so is there work being done to this system? We know that there's kinetic energy to begin with, and then since the object's at rest against the spring, all of that kinetic energy goes away. It goes into the potential elastic energy. So, because we have a spring, right? So we have potential elastic energy at the end. Now, the energy isn't leaving the system, or there's no energy coming into the system. Our energy is just being transformed. So do we have any work? Nope. So there's no work. None. Alright, just a transformation of energy. So our conservation of energy equation is just going to be kinetic energy equals potential elastic energy afterwards. Okay? So then we need to solve for K. So we can fill in our variables. Kinetic energy is 1/2 mass times the velocity squared, and potential elastic energy is 1/2 our spring constant K times x squared. So we'll plug in all of our variables. We should have everything except for our spring constant K. So here we have 1/2. Our mass is 13 kilograms. And our initial velocity was 4 meters per second. And that's going to be squared. Guys, don't forget that. And then we have 1/2 K, which is what we're trying to solve for, times our x squared. And it was compressing a spring 0.5 meters. So this is 0.5 squared. Alright. So now we're going to multiply all of our work out. So we're going to take out our trusty calculator and do 1/2, which is the same as 0.5, times 13, times 4 squared. And we get 104 on this left side. And then on the right side, we're going to have 1/2 0.5 squared. And we're going to leave our K alone right now. So 0.5 times 0.5 squared. And we get 0.125. So 0.125. And then we still have K, which is our spring constant, which is what we're trying to solve for. So what we have to do is get K by itself. We have to divide both sides by this 0.125. So we're going to go ahead and do that. And on the right side, these cancel out. And we want to know what is 104 over 0.125 equal to. And it is 832 newtons per meter. So we actually have 832, so we'll check that, yep, newtons per meter equals our K. Alright? So that is a lot of force, a lot of newtons that you have to apply per meter to get that thing to compress.